unit calendar from the yellow, set of notes from the red folder, and then just hang tight while we get organized camp. Thank you for putting up your name tag so I can see. I'm actually doing pretty good with this class because there's not many at all, but if you can put that up, that'll help me out. How's the day going so far? Good. Day 2? Are they long classes? 72 minutes? Man, I've only taught one other pre-cal class so far. This morning I teach like a algebra USC course first period, and then I taught my pre-cal class. But it was actually, for me it was kind of nice because I always feel kind of rushed in the lessons, so it's kind of nice for the first one for us to feel like we have enough time. But stick with me because I know it's a long time and you're on your 3rd class, so you're getting ready for lunch and all that, but stick with me. So here we go. Just in general about class, a few things to add on that we didn't talk about yesterday with the syllabus. I pretty much every week on Monday is the day I tend to like hand out papers for the week, kind of, or the beginning of a unit or things like that. And what usually will happen is I'll put folders like this in the middle of the table, and it'll have instructions up here of like what to grab. And then for the most part, you just continue to bring things, and that way I don't have to pass out papers every day and waste time with that, if that makes sense. So that's why if you can be getting that binder or folder by next week so that we can hold all of your pre-cal notes, that would be great, because you will bring the notes like day to day and just keep adding on to them throughout the week. Today's notes are just for today's class, and you'll get a new one on Thursday while we kind of sort things out at the beginning of the school year. But this folder system is kind of how things will work in terms of getting papers. Cool? Other than that, you had 2 tasks that I gave to you yesterday. First one was to read through your syllabus again and then get that last page signed. You didn't have to do that until like Thursday is the last day I'm going to collect those. But does anyone have it today? If you do, you can get it out, rip it off, and you can make a pile of it on your table, and I'll come around and grab any of those so that you don't even have to think about it. If not, friendly reminder to do that by Thursday so that I have it. And the second task was to do what? Does anyone remember? Yep, Alba? Email me, and I have in this class quite a few people that emailed me. I had Lema, Jonathan, Angelica, Edo. I had it, but then I didn't think it was. Okay, Jordan, Tanya, Alba, Eileen, and Nen. Did I miss anyone? Those people are going to get a prize for following directions. Don't you love prizes? I love it. So no punishment, no consequence today for those of you that did not follow directions. But if you could email me as soon as possible, and people that did it in a timely manner, thank you. I'm going to bring you something here in a little bit. Cool? Yeah? Sound good? All right. So that's all we have in terms of business. Moving on, if I can get you to take a look at that piece of paper you got out of the yellow folder, our unit calendar. At the beginning of each unit, I will give you a sheet of paper like this that basically lays out everything you need to know about the unit to be set up for success in terms of dates and grading and things like that. So on the front, it'll look something like this, and it has all of your card problems. I'll go like that. It has all of your standards broken down. Remember we talked about yesterday how 90% of your grade is coming from like quizzes and tests, and that'll be coming in this unit from these 3 standards right here that are laid out about functions. 5% of your grade is going to be coming from participation, and we're going to start that next Monday, and then 5% of your grade is going to be coming from your problem set homeworks that are due on Mondays, and you'll get your first one today at the end of class. Cool? Any questions about how the standards work? All right, flip it over. On the back, I'll always give you a calendar so that you can see when things are coming up. For example, right here it says intro to pre-cal. That's what we did yesterday. I messed up and I left it as Miss Cott. I'm like trying to get things transferred over. Mrs. Rohan, Miss Cott, whatever you want to call me. Today and tomorrow I'll be teaching the same lesson because I won't see you all tomorrow, but I'll see some of my other students tomorrow. And then we'll be moving on Thursday, Friday, and so on with all of these lessons if you're curious. What you really need to watch out for though are these things that are highlighted. So these are your problem sets, which are due on Mondays, except for this one because we don't have school that Monday. Okay? And you'll get your first problem set today, and it'll be due on Monday. And then you need to watch out for your quizzes and your tests. When's your first quiz? 29th. So it kind of seems like a long way away, but we'll be preparing for that. And then you'll have a second one right before your unit exam, which I'll usually do that so that this gives you a good idea. It's almost like a fake unit exam, like a good test to see how you're doing. And that will guide my review so that I know like, ooh, they struggled still with this, I'll grade them that night. And I'll be like, that didn't look so good on that, and then I'll review it the next day, so hopefully you can do better on the unit exam FA, right? Cool? So I don't recommend waiting to the unit exam to get your act together, but you've got multiple opportunities to kind of like improve throughout the unit. Cool? Questions? All right, so you can put this away. If you have your pre-cal folder, binder, whatever, put it in there so that you can get it whenever you need it. If not, put it somewhere safe until you get one and are set and ready to go. Whoa, whoa, whoa. There must be some sort of, okay, I'm getting used to my new clicker. Did I tell y'all last year I had a clicker, but I used the like laser so much that the red dot, like you couldn't see it by the end of the year. And I thought it was like a battery issue and I replaced the battery, but I realized it was literally the bulb like had burnt out because I used it so much. So I got a new one. Higher quality. The last one was from Amazon. It was like $5. I think that's why I did. Okay, so today we're going to be jumping in to quadratic functions and equations. This lesson is not specifically like a pre-cal topic, but it's going to support what we do in pre-cal. It's supposed to be more of a review of things that you might have seen in Algebra 1, Algebra 2, etc. However, from previous years, we've noticed that these are things kids struggle with. That's why we're reviewing it. So if you feel like we're going over it and you're like, she just said this stuff I should have already learned and I like really don't know where to start, that's okay. We're kind of re-teaching it to make sure we're all up to speed, right? Okay? So starting with this first activity right here, let's read what we're going to have to do, and then I'm going to kind of set the stage and then release you to kind of talk about things with your neighbors. So can I get, Dennis, do you mind reading for us just right here where it says for the parabola?
For the parabola shown below, the vertex located at -2, 3, determine the missing coordinates for each of the legal points. Be prepared to share your reasoning with the rest.
Okay, so we have here a parabola, and it gives us this thing that we call the vertex at -2, 3, and it asks us to determine the missing coordinates right here all over the place. Now I'll tell you, it is possible to find the exact coordinates at all of these locations if you were to like perfectly remember everything you've ever learned about parabolas and quadratics. However, this is a challenging problem. Like, I'll be completely transparent. The first time I saw this problem, I used this from some resources that like the whole pre-cal system uses. And when I jumped in, some of them I was like, I think I just like, I mean, it's like if this is up here at 3, then this is maybe like around 2, and I just used estimating to figure out some of them, okay? And that is okay. So as you're going through, I want you to know that you can find the exact answer without estimating, but if you're not sure and don't remember how, I want you to at least estimate or use like what's reasonable to try to figure out as many of these as you can. And I don't expect you to feel 100% confident about all of them, but I want to see if you can at least figure out a couple. Does that make sense? So don't be discouraged by this if you look and you're kind of overwhelmed, right? Okay, so I'm going to let you talk with your neighbors, and your challenge is to just like get talking about math and see if you can figure out as many of these as you can. For the first minute or so, it's okay if you need to just kind of silently look at it on your own. In my last class, they were like silent people. But then I want to really encourage you to turn and talk with your neighbors about what they notice and things like that. Cool? Okay. On your mark, come up with as much as you can. Get set, go for it. Estimate and measure. Okay. So that's why maybe you're a little close, but like a little bit off. You go like estimated. Okay. Interesting. Very good. Keep trying.
Yeah, like this. So for this one, which of these do you feel more confident about? The zero or the one? The zero, right? Like things that cross our x and our y and help us out. So it's a good starting point.
Okay, that was like 1 minute of kind of taking a look on your own, and some people already started talking, which is great, but I really want to encourage you to also include people around you, because people might remember different things. So at this point, I should definitely hear talking at like every table. I'm going to give you still like 4 more minutes, you got plenty of time. Go ahead and talk to each other, ask for help, all those things. Go for it. Cool, so the x coordinate, are you sure that that's at 1? Yeah. Cool, okay, so that one you're like, maybe, but then you feel confident in the 0 because you know it's crossing here. And then for this one, you feel confident in this 0. We'll kind of see about the other one. Okay, cool. So that's a good starting point. So she used the fact that it crosses the x and y axis to know the zeros. Very good. Good. I see a lot of people with this 0 and 0, which are good. Let me come back also to this 4. In terms of, what do you notice about a ground if I were to draw a line down the middle right here? So like the same or different? The same. So this is like a line down the middle. Can you figure out how wide from like -4 to -8? Right? And then make sure it's this wide a little bit on the other side. Cool, very good. So, can you talk me through where your -5 is? For the A? Yeah, cool, okay. And that ends up actually based on that point. Cool, so you're thinking, yeah. Let's think about this one. So it's kind of related to this guy, right? So think about if there's like a line on here. Let's talk about this one. Sorry, this 8 you're thinking this is an 8? Is that why we wrote it there? Why not? It's not perfectly in the middle, right? But can you find the middle? Find the middle is actually like shifted over to -2. So see if you can still figure out like how far over here and how far over here. Okay. Okay, time check. I get about a minute and a half left for you to just kind of keep thinking, and then we're going to dive in together, see what we think. Oh, I have to get out my glasses. They're both those are still. Or you don't have to take them. message?
Like, I gotta go like.
Thank you. You're on it. You email me. Dennis, you email me.
On Thursday.
Cool. I think, yeah, well, yeah, that sounds good. Bye, Thursday. And who was it? Zulema. You don't have to eat it. I'm not forcing you to eat it. But would you like to take it? Maybe
Wait, I
someone
don't like
else wants
sour
it.
candy then. If that was like this, they tell me.
Switch. Alright, cool.
Oh, do you want my sodas?
Always.
What?
Do you want my sodas?
Oh, did I not get to your table?
No.
Sorry. Okay, let's wrap up those conversations and take a look and see what we came up with. So, I saw a lot of good things as I walked around. Again, some of these coordinates were probably a little bit trickier to find than some of the, don't look at that, than some of the others. Let's see where some people might have started with. Eileen, I'm going to start with you. Which of these points or points did you maybe go to first and think that you might know something about?
For C, the y-axis, I thought was 0 because it stayed the same.
Okay, the y coordinate, she says right here, she knew was 0 because it crossed the x-axis, which means over here it was at 0. Okay, cool. Any others that were kind of like that?
A,
For A, over here, we also knew that this was, did I do the right one? Yeah. Sometimes when I'm standing up here, I put things in the wrong spot, so please stop me. Don't let me go like 10 minutes before I'm like, oh, this is wrong. Okay, so 0's right there. Okay, anyone else? Anything similar to that? I heard someone? Alba? B? Okay. B crossed the y-axis, so which one do we know is 0? The x coordinate. Okay, so I saw a lot of people that ended up plopping a bunch of 0's on there to start off with because they felt confident about that. Okay. Then I saw some people here for like C doing maybe some more like estimating around what did you think maybe could be the x coordinate here. I saw a lot of 1s as I walked around. Okay, we're gonna hold off on B like writing that right now. Might be good. I don't know. But for right now, let's maybe make sure we can prove it before we like commit to it. Right? Okay. Let's think if there's any others that right off the bat we see. I already gave one of them away, E, because I like accidentally clicked on here. So let's maybe talk about E. You might not have seen what I had, because I did see some people that were able to figure out this one. Any brave volunteers down here for E? Jonathan, take it away.
You see the coordinate -8, -9. That's basically the opposite of that one.
Okay.
So using the axis of symmetry, you can tell that -8 is 6 away from -2. So E should be 6 away from -2 as well.
I love that. So in that vocab word, we're about to learn it in a second if you didn't already remember. We call this imaginary line down the middle of our parabola the axis of symmetry. A parabola is symmetric on either side. So Jonathan, notice these starred points that I started here are very similar, right? They're just opposites on either side of the parabola. So if this is 6 away from the middle, this should be 6 away from the middle. The tempting thing maybe right here was +8. Like if it would have been centered around the middle, a couple people were like, oh, -8, +8. But if this is over here at -2, 6 away would be +4. Cool? Okay. Any others that jumped out at people as like, oh, I got it? Or were we kind of stuck at this point? Estimating, things like that? Okay. Jonathan?
I wasn't sure about C,
Uh-huh.
but I'm guessing that B is the x is 0 and D the x is 2. I'm
The
guessing
Y? Right here?
No,
Oh.
and D the x is 2.
Ah.
I'm guessing because it's in the middle, maybe C the x is 1.
Ah, okay. So we're thinking like 1 maybe here. Any estimates for B? 2-ish, something like that. They literally look the same. My question mark, my 2. That's great. You'll learn I have pretty bad handwriting, so bear with me. It's bad. I promise it used to be good. My mom was like, I don't know where we're wrong. It was good in elementary school, and then it just terrible. Anyways, so 2, 1-ish, we don't know, maybe same thing over here for A, we could estimate, for D, maybe we could estimate, okay. So here's where I want to kind of like draw us back together. I didn't see anyone write this down, but I'm going to write down a more like formula equation for a parabola that maybe will jog your memory a little bit, that I didn't expect you to remember, but maybe once I write it, it might like, some of you guys might be able to remember. So, who thinks, you can just give me some like nods or some like, nope, never seen that before. Anyone ever seen this equation here for a parabola? Look familiar maybe a little bit?
Yeah.
Okay, yeah, okay. This is what we call vertex form of a parabola. So parabolas can be written in vertex form using the points on our graph. So if you remember this key formula from our parabola, we can start to plug in some information that we know and use it to kind of find some of these missing points. For example, H and K are something special from our parabola. Does anyone, now that I've written this, think they might recall where H and K are going to come from in our picture? Go for it, Gladys.
It might come from the X or the Y.
Yeah, this is going to be an X and Y coordinate, but it's a special coordinate on our parabola. Do you know where it is on our pretty picture? It's on the axis of symmetry. It's on this, and the only point that's on the axis of symmetry that's also on our parabola is where? Right here, the vertex. I need like another color. This green is getting out of control. I like multiple colors. We'll make it blue because it's special. Here's the vertex right up here at the top. -2, 3. That is HK in vertex form. That's why we call this vertex form, because we can easily see the vertex right here. So we could rewrite this as y equals a, x minus a -2 would be what? Minus a -2. How could I rewrite that? +2. Thanks, Tanya. And then plus our k is +3. Okay, so we're closer to almost having the equation. We're close to just having an x and a y, but we still have this a like hanging out. But they did give us enough information to solve for a. To kind of move us along, I'll kind of keep pushing us forward. They gave us this point right here, -8, -9, which means I have an x and a y I could plug in, and then I would just have one variable left that I could solve for. Y'all with me? Let's try that. As I write it down, maybe it'll kind of come to you. So what y coordinate do we have over there? Y'all like, you can say it a little louder, because I think I hear you, but then sometimes I'll like say the wrong thing. What'd you say? What's the y coordinate? Okay, cool, that's better. -9 equals a, what's the x coordinate that goes with -9? -8 plus 2 squared plus 3, and we should be able to use any point. Like technically we could also actually use this guy over here. I didn't mean to like commit you to that other one, but since they didn't give us the 4 originally, if you didn't figure that out, then you would have had to use the one they gave you. Yeah? But we could use the 4, we should get the same thing. Okay, so now let's go ahead and solve for A. We're just solving an equation. I'm just gonna like keep us together right here and have you guys like pop and tell me what you would do first. Andres, what would you do to start simplifying this to solve for A? Cool, which is? Good, -6, so I got -9 equals A times -6 squared plus 3. -6 squared, don't let it trick you. Negative times another -6 is what? Positive 36A, and I'm going to switch it because by convention we tend to write the number and then the variable, right? But this is 36, and then we get our A plus 3. Okay, keep it moving. Love if I see people writing this down. Move that 3 out of the way. What do I have on this side? Anyone? -12 equals 36A. And then last step to solve for A, we're going to divide by 36. And don't let it intimidate you. I know this is kind of a weird, we love like pretty numbers, and this ends up being a fraction. But A is equal to negative, when you simplify that, 1/3. Divide by 12 on the top and on the bottom. a is equal to negative 1/3. So, over here, our equation now becomes a is negative 1/3 times x plus 2 squared plus 3. So they actually gave you enough information from the beginning. If you were like, oh, I remember everything from Algebra 2 and I'm a genius, you could have written the vertex form of this parabola, and then once we have this vertex form, can we find these other points? For example, let's talk about D. We're not going to do all of them for the sake of time. What could we do now to find the y-coordinate for D? So Lama, do you have an idea? If we know the x-coordinate is 2, and we have this equation, what can we do to find the y?
Well, we can use that,
Ideas?
plug it in.
Plug it on in. Go and say 2 plus 2 is 4. I thought for a second I like, okay, 2 plus 2 is 4, squared is 16, times negative 1/3, plus 3, all of that. It gets nice and messy, but I'll pretend it's like a cooking show where like they like put it in the oven and then it like magically comes out and it's done. When you do all that math, when you plug it in there, we end up with negative 7/3, I believe? No. Yeah. What? Yeah, that's what I got. We're gonna just fast forward for the sake of time. So it's possible to get it, but like, would you have been able to do that just by looking? Probably not. But that should be close to your estimate. For example, up here, 2 is actually not quite there. It ends up being 5/3, but 5/3 as a decimal is like very close to 2, right? So it makes sense. Whoa! So that's a little bit to kind of recap about the vertex form of a parabola and kind of get our minds going with that. Today, we're going to be kind of talking about some of these terms with the parabola, like Jonathan already included axis of symmetry, and then we're going to be talking about another form of a parabola called standard form that you might have seen. Okay? So join me right here for, oh, and if you were curious, these were some of the other ones. We get them? If you're curious, those are the other ones. Moving on. Let's talk a little bit about some vocab and get that down so that we make sure that we're using the right terms when we're talking about the parts of our parabola right here. Okay, so this is vertex form of a parabola, and the first vocab word we've got right here is axis of symmetry, which Jonathan already used, and that is that imaginary line that runs down the middle of our parabola. So we can say right here as our definition that it is the line that divides the parabola into 2 halves that are reflections of each other, because a parabola is symmetric. So it goes right down the middle. It's not actually there, but look at my fancy animations in my PowerPoint. Boop. There it is in our example from earlier. So I like to draw it so that I can see. Okay. Give you a second to jot that down. Next, we also talked about the vertex. In your own words, Angela, what in your own words is the vertex? Did I get that right? Angelica? Yeah. See? Can you put it up for me? Thanks. In your own words, where is the vertex? What is the vertex? Okay, something about like the center or like the starting point of the parabola. Okay. Alba?
It's the highest or the lowest point of a parabola.
Okay, so it's either going to be lowest if it's like this, highest if it's like this. Okay, that's another way we could say it. Cool. It's also always going to be the point where that axis of symmetry intersects the parabola, because that line will always go through at that point. So the point where the axis of symmetry intersects the parabola. I like what Angelica said, like the center, the starting point of the parabola. And then, kind of like Alba said, It's either the low point or the high point, but I'm sure you've heard these terms before. Kind of a stronger math word for high point would be our maximum, or our max. We've heard that? Or low point, minimum, min, for sure. Okay, so we will be referring to those pieces as the axis of symmetry and the vertex. My PowerPoint's kind of like on the thingamabobber right here, but you'll see right here that it asks you to find the axis of symmetry for our example and the vertex for our example. So the way we would write our axis of symmetry is a line, right? And it's a line at a certain x value. So we can write x equals, and what does x equal in this example? What does it equal? Negative 2. Weird. I couldn't hear again if you said it or not. X equals -2, and then your vertex is going to be coordinates, a point, and what is our vertex? Say some up. Louder! What's our vertex? Thank you. I have terrible hearing. Cool? Okay, moving on. So we learned vertex form of a parabola. Flip. Up here. But parabolas and quadratics can be written in multiple forms, and in different cases it might be helpful to have one or the other, right? So in this one, it was really helpful because it just gave us the vertex, right? What we're going to learn now is something called standard form, and this is the standard form of a parabola. It looks like this. Has anyone seen that before? Okay. So y equals ax squared plus bx plus c. And this one is helpful because we can find the vertex. It maybe takes like a few seconds longer to find the vertex, but we can easily from this find the y-intercept, and we can find the axis of symmetry. Okay, so that's what we're going to focus on doing today. We're going to be finding the y-intercept, the axis of symmetry, and the vertex given something in standard form. Okay, so let's talk about the y-intercept first. Remember, where it crosses the y-axis, x always has a specific value. What is it? 0. So we can plug it in, kind of like we plugged that other one in, to here, and we'll have a times 0 squared plus b times 0 plus c. And if this is 0 and this is 0, it's going to cancel out all that, and what will we just be left with? C. So always, 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 in standard form, it's going to cross the y-axis at just that number right here off by itself, our c value. Okay? So if I give you, where is it going to cross the y-axis? 5. Like super quick in standard form, you can see where it's going to cross. Okay? That's why standard form is helpful. Cool? So we got the y-intercept. Boom. It's C. Next, the axis of symmetry. Kind of a weirder one. The axis of symmetry is always going to be the x equals line where -b over 2a is going to give us the actual value of the number. So we're going to use this b value and this a value and plug it in, and -b over 2a is going to give us that axis of symmetry. Okay? Lastly, the vertex. Remember, the vertex is on the axis of symmetry, so it's going to have the same -b over 2a, except it's a point, right? So that's going to be the x-coordinate. Whenever we have an x-coordinate, what can we do to find the y-coordinate?
Plug it in.
Plug it in, just like we did earlier with that other one. So if we plug it in our equation, we'll always be able to find the y. So one way you can write that is f of -b over 2a. And I'm just going to write right here, plug it in, and then when we see an example, you'll have it in your notes to remind you. Because this should be a coordinate, right? We're going to use -b over 2a, but it should be an x, y point, right? Okay, let's use an example. You've got a little bit of space right here on the side, okay? Before we get to the practice where it says, show me what you can do. Oh no. Let's use this example right here to kind of really quickly find the y-intercept and all of that and make sure we feel good about it, and you can ask me questions. before you go on and do one with people around you. So first up right here, and if you want to like write this example, like good note taking next to it, you're welcome to do so. If you want to find quickly the y-intercept, that's going to be where? Which is what in this case? -5. So it's going to be down at -5, so it's 0, -5, okay, for the y-intercept. For the axis of symmetry, I'm just going to write AOS, shorthand. We're going to say x equals -b, and Edo, what's b? 4 over 2a. Cecilia, what's a in our example? This one right here, if this is ax squared plus bx plus c, what's a? The -2. And that simplifies to 1. -4 and -4 gives us a positive 1. Cool. Okay, last step, the vertex. What's the x-coordinate of our vertex if we know our axis of symmetry? 1. Good, Alba. And then we're going to plug it in to get our y-coordinate. So we're going to just put it in this equation. And let's see if we can do this in our head quickly for the sake of time. 1 squared is 1. So that'd be -2 plus 4 minus 5. I believe it would be -3. 2 minus 5 is -3. Right there. Okay? Y-intercept, axis of symmetry, vertex. So you could pretty much sketch this problem, which is what we're going to be doing. Questions about that before you go do an example with your neighbor? Feel okay? Look at this example as you work through the next one, and call me over if you have questions. I'm going to give you guys just about 3 minutes, and then we'll see where we're at on time. Maybe 4. I'll give you 4 minutes to find the axis of symmetry, y-intercept, and vertex of this equation right here. Okay? Go. If you need to like literally write down and identify A, B, and C first, you can do that. Perfect, yep, and then just don't forget it's a negative in front. Negative b over 2a. Just don't, yeah. It actually doesn't matter whether it's on the top or the bottom because it's just like a -1. Let's see what we got.
Basically,
Good job.
and after you get X, you plug in stuff.
Okay.
You plug into the
You
function
guys
you get.
want to chat about it or do you want?
Yeah.
Yeah, okay, you
Fine,
guys
but six
talk
is
it
fine.
over and you know, call me over.
You have to plug in the X.
What are we doing? Okay, so it's always, since these are parabolas that face like up and down because they're functions, it's gonna be x equals something because it's a line, a vertical line. So x equals, and then it's negative. So always put a negative out front, and then b is what in our example here? So if it goes a, b, c, b is gonna be 2. So negative 2 over 2a, and if there's nothing in front of the x squared, what coefficient is there? 1. So 2 times 1. Cool. And then 2, 5, and then you're good. Okay, so you put a negative on both, yeah, just one negative. And so then it's gonna be a negative 1. And then plug that in. Okay, so for the vertex, it's a point on the graph, right? And so if you know the x coordinate, you should be able to find the y coordinate, because the y coordinate is the answer by plugging it in right here. So the x coordinate is going to be negative 1. And then plug it in here and see what your y coordinate is. So negative 1 squared, okay, plus 2 times negative 1 minus 3.
This one's right. Right, like this and right to the.
Perfect, and so just be careful when you square this, since the negative is actually like under the exponent, it's gonna be a positive when you square it, because a negative 1 times a negative 1 will be a positive. But then 2 times negative 1 will be minus 2. Okie dokie, how are we doing on time? Are most of us, I think I only saw a few people that are kind of finishing up. Alrighty. Here we go. I love when I have a document camera because I would probably right now like grab one of y'all's work so that you don't have to like sit here and have me do things over again. But I'm gonna kind of do somewhere in between. So as we go over this, I'm not gonna go over everything because I saw a lot of people that had stuff as we walked around. But I am gonna have to write some stuff down, so kind of bear with me. Okay, so here we go. We've got ax squared plus bx plus b. Really quickly so that we make sure we know what was a, 1, b, and c, negative 3. That's all the information we need to be able to now find all 3 of those pieces of information. Let's start with the y-intercept. Because c is negative 3, that will be at the point 0, negative 3. Let's go ahead and start actually plotting these things now, since there's a graph down here, now that we found the information while we're going over it. So 0, negative 3 would be down here. So we know it's going to cross the y-axis down there. Okay, interesting. Let's go over to our axis of symmetry. That's where we use negative b over 2a. So x equals negative 1. The biggest issue I saw here is maybe a couple people having positive 1, depending on whether they forgot the negative out front or like not knowing whether it goes on the top or the bottom. It is 1 negative out front, but technically that means it could go to the top or the bottom, but not both. Okay? And we'll talk more about that throughout the year in terms of like with math, like what negatives mean and why, where you put them and all that kind of stuff. But just in general, that's what was going on there. Okay, so that means over here at negative 1, we've got our imaginary line hanging out. That our parabola is going to be reflected around. Okay. Next up, our vertex. We take negative 1 as our x-coordinate. And once you plug that in, assuming all of our math was okay, you should have gotten negative 4 right there. Do we feel okay about that one? Okay. So let's go ahead and plot that. Negative 1. Oh, geez. This is like the worst board ever. Whoop. It'd be like right there, right? Y'all see it? So on your paper, plot negative 1, negative 4. But on mine, it goes below the board. Sorry. You can figure it out. Cool. Okay, so we have 3 pieces of information, which is enough for us to draw a sketch of our parabola. It's not going to be perfect. We don't have like where it's going to cross the x-axis. We can solve for that, but I'm just worried about these 3 for right now. In general, if it starts right here, it could go this way around our axis of symmetry, or it could go up around our axis of symmetry. Based off of our y-intercept, which way must it go? Point for me, up or down? It's got to face up to be able to, I can't draw it right here. Ah, I wish I had a better, can you all imagine the point right here? To pass through here, it's got to go up to pass through there. I'm going to sketch it over here because that was like a bad example because of the board situation. Yeah, since this is the bottom, or we didn't know it was the bottom, but since this is the vertex, it must be the bottom, a minimum, to go through that y-intercept, right? I don't care for the sake of today's class where we're crossing the x-axis. We'll talk more about that later when we get to roots and zeros and things, okay? So for now, this is all I want you to sketch for today. Are we alive still? Falling asleep? Okay, we're doing okay. So I went ahead and, just so that you could see it, also graphed it on my calculator to check my work. And voila, it looks like our picture. And you can actually see where it does cross the x-axis, even though we didn't find that, but it makes me feel better about what I did. Cool? All right, moving on. I want you to go ahead and, it says model, but I feel like you're doing so well. I'm going to have you go through this and do the y-intercept, axis of symmetry, and the vertex, and sketch your picture, because once we have a picture, you should be able to figure out and answer this question whether it has a minimum or a maximum. For example, in the last one, after we drew it, what did it have, a minimum or a maximum? Minimum, right? So take a look at this new equation. I want you to go ahead and find the 3 pieces of information and graph it, and use that to determine whether it's a min or a max of our parabola. Go for it. Lovely, wonderful things. I like to start with my y-intercept just because I find that to be the really quick one with the c value, but you can do it in whichever order you would like. Good start.
So because it's a negative out front, and then -6, 2 negatives.
So I like to just still draw the one out front so that then, like, whether that top one's positive or negative, I can see whether there's 2 or whether there's just 1. Yeah.
It's -6.
How do you get Let's see here. So this is your, what do you got from negative b over 2a, or take this one? Let's see, so negative, let's write it down. So negative out front, and then what's b?
Let me.
Can I just think about it for a second? Yeah. Okay, I'll be back. How we doing? Good. I know, that's the hardest part, I feel like.
Yeah, that's a good fraction or that's.
Yeah. So, You can do either. If you do a decimal, then I don't mind if you plug that in your calculator to find the y, because it's going to become pretty messy to do 3/10 in this whole thing. Yeah. Great. Good. Woo. Wonderful. Good. Very nice. Okay, about 15 seconds, and then we're gonna see where we're at. Is that better about the top?
Yeah, that was like.
You kept a 2 on the top, but that was just because this was 2, right? Cool, okay. He sees it. Okay, boom. All right. We took a look. Let's check over a few things and see how we did. Vertex. I didn't know what was gonna come up. First thing I've got up here for you to check is your vertex. You should have gotten an axis of symmetry over here at 3. And when you plug it in, you get -8. Did I count that? 1, 2, 3, 4. Seems so far down there. Okay. And then your axis of y-intercept is at 0, 1, because C is 1 up here, which I saw a lot of people have. And then just do your best to sketch something that's like pretty bad because they crossed at the wrong spot, but you know what I mean. That crosses at that point, and we don't know exactly what's been going on here before that, but it doesn't have to be a perfect picture. Just do your best. And it should have those 3 things in the right spot. Cool? So therefore, was this a minimum or a maximum? Nice and loud? Minimum, because it was the facing up. Oh, got it. Minimum. And the actual point of the minimum was 3, -8, because that was our vertex. Happy so far?
No, I'm not happy.
Not happy.
I don't know how you got the -8.
Good. Thank you for asking. I like when people, not when people are unhappy, but I like questions. So stop me. Okay, so we took the 3, and because this is a point on our graph, it should be able to, if I have an x coordinate and I put it into my equation, then like my output will be my y coordinate. So I just am taking, what is it, 3? 3 squared minus 6 times 3 plus 1. 3 squared is 9 minus 18 plus 1. 9 minus 18 is -9. Plus 1 is my -8. Happy? Woohoo! I love it. Cool. Sometimes the negatives are kind of, I don't know what it was. But okay, and then we graphed it. Done. If I graph it in my calculator, it looks the same. We'll be doing more of that later in the unit. And last thing is it asks for the domain and range, which we haven't talked about yet. So let's kind of hang out here. In my first class, you guys might be different, which is totally fine, but they actually felt fairly comfortable, I felt like, compared to maybe even my students last year, with domain and range from previous experience in like algebra and stuff. So domain and range are talking about of our graph are possible x and y values. Does anyone remember which one's which? Jonathan?
Domain is x, range is y.
Okay, so let's talk about our x values here. Anyone have an idea of what are possible x values for our parabola here? Oh, you keep going.
All real numbers?
All real numbers. If these were to keep going, we can have any x coordinate that we can plug into this equation. So we can write, domain is all real numbers. You can write it like that. Some people might have seen that big R like this. Interval notation, which we'll be learning a little more formally later, but I know some of you have seen negative infinity to infinity. Do we like that notation? Some people? Okay, so for right now, use whichever you like. We're going to be doing interval notation a lot this year. Okay? Now let's think range. if I am going up and down, I don't have any points down here. Where's my first point start? -8. My first y coordinate, right, is -8. And then I go on forever. So any, you can't see, y values greater than or equal to -8. Or you could write this as -8 to infinity, and I use brackets because we are including -8. So that's how we would write the domain and range for a parabola like this, and we'll keep practicing that. Yeah?
Explain the order numbers thing.
Okay, perfect. So for our x, our y, see how it stops right here at -8? Even though we cannot see the entire graph, there's never a point where this stops going this way, right? Technically, if I went all the way out and all the way out, up there somewhere, there's still a point forever and ever. This parabola is going to go on forever and out forever in the x directions to positive infinity, negative infinity. I could pick any 1,000,003, and I can pop it in here and pop it in here, and that would give us a point. 1,003, comma something, right? So there's any possible x values. It's just kind of weird because we don't see them. But it's not like -5, 7. That just happens to be my window on this one graph, right? It would go forever. Yeah, does that answer that one? Okay, cool, good question. Last thing, we're doing good on time. Okay, last thing, stick with me, long class today. About minimums and maximums, what y'all did is you actually graphed it and then you just looked and you said like, oh, I see it, it's a minimum, or I see it, it's a maximum, right? Actually, just from looking at, what am I doing? Just from looking, oh geez, I know what happened. My computer died, I think. Just from looking at your standard form of the equation, you can figure out a minimum and maximum. So this is another benefit of having standard form. Here's a little trick to figure out whether your graph has a minimum or a maximum. Stick with me. It says in that little box right there, if A is greater than 0, right? Y'all see this part while my computer's getting back up?
Yeah.
It says that the parabola looks like what? What does the picture look like under down? Facing up or facing down? It's like a U like that. Facing up. Cool? If A is less than 0, your parabola is always going to be facing down. So actually, you can take the time to draw it. I love drawing it. You're going to have to draw it a lot. But you could just glance at the equation and look at A, and A should give you all the info that you need about whether you've got a minimum or a maximum, because you'll know which way your parabola is facing. Let's try this. Da, 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 da. Please. Yep, there we go. So if it's positive, A, it's going to be a minimum because it's facing up. If it's negative, it's going to be facing down, so it's going to be a maximum. All right, so without graphing them, a real quick check. I'm going to give you 3 equations. I want you to give me a 1 on your finger if you think it's a minimum, a 2 if you think it's a maximum, using just positive and negative A values, okay? So here's 3 of them. First one, everyone show me either a 1 or 2 on your finger. First one, taking a look at f of x, does it have a minimum or a maximum? Good, I see lots of 2s. It has a max because it's negative, so it's going to be looking like this one right here, right? Cool, next one, show me. Min or max? Good, 1, it's going to have a minimum because it'll be facing up. And last one? I see 2s and 1s on this one. Tanya, why is it a 1?
Because it's positive.
It's positive, so it's facing up, which means it's a minimum. So if there's nothing there, it's like a positive 1, right? So positive, positive, oh no. Positive, positive, these were minimums. Negative, this was a max. Happy? Okay. All right. That's all I got for you in terms of material. So we've got a few more minutes left. What I want you to do is finish for me one of these problems right here, either g of x or f of x, I want you to find the axis symmetry, y-intercept, and vertex one more time and graph it so you feel really good about it before you leave here. And then we're going to close by talking about our first problem set and how that all works. Okay? Try one more. You pick. What? Oh, you thought you completed the problem set? No. You haven't started yet. Sorry. Yeah, so what I would do is I'd start to sketch it. At first I was like, what if I this one too? And you'll notice once you sketch it, that because these both have 13, it's kind of like that situation earlier with the -9s, where you should be able to find the middle and like make sure that that's the point that's like on the middle, right? Because the vertex should be on that axis of symmetry. Yeah? Okay. So you can say with certainty that that's the one. Okay, for today, since we don't have an exit ticket or anything like super formal, and this is like not a quiz, obviously won't help you look at the answers like and just write them down, but since I see all of you guys working, I'm just gonna put up your answers so you can kind of like, depending on which one you did, check your work as you finish and make sure you feel good to go. And if you don't feel good to go, like we talked about yesterday, I'm available to help out. We're gonna move forward Thursday with zeros and roots and like factoring, but we'll kind of keep coming back to this, and this will be on your problem set, so you can reach out to me if you have questions on your problem set, okay? Okay, give about one more minute and check over, and then we're gonna talk problem set so that I can get you out of here on time for lunch.
Did you hear?
No, he gets to go to the rock this time. Did you like eating in here? You're moving on. It's kind of nice. And then you get to go home. And we get to go to meetings.
So we're with 10th graders and 12th graders.
Yeah, 10th, 11th, 12th. Which y'all were in there last year, right? Because y'all were, said y'all have the new 10th graders. Okay. Very good. So hopefully, I encourage you to, you can always finish these practice if you feel like you need more practice, but you're going to get the majority of your practice from your problem set. So I'm going to spend our last few minutes talking about the problem set. If you can grab for me out of the blue folder, a problem set for me. Out of the blue folder. In general, problem sets will always come from the blue folder. Usually I'll give them to you on Monday and you'll have a full week. This week, because yesterday was just an intro, I'm giving it to you today. Also, note that I have one of these handy dandy dealios with a yellow, red, and blue folder always on my cart and always in my main room, which is 121. So if you ever lose track of your problem set, this is important. If you ever, oh, there it goes. If you ever lose track of your problem sets, you can grab an extra one off of my cart or from my room. So Friday, you're like scrambling around and you're like, oh man, my problem set's due Monday and I don't know where it is. Come grab an extra copy so that you can make sure to get it in on time, okay? So here's how the problem set works. On the top, you'll see the due date, the 21st, which is next Monday. Throughout the week, I'll give you updates after class of like, by now, based off of what we got through, you should be able to work through blah, and we'll continue to like build throughout the week, Okay? So for example, today we did lots of examples like this, right? You technically should be able to complete the first page, and that's usually how it's going to be. I try to do it kind of by pages, where you can do these graphs, and then down at the bottom, you should be able to do that domain and range. Note there, the domain and range end up being like decimals or fractions. So it's okay if when you get that decimal or fraction x value, to plug it in, you like use calculator or whatever to get your output range, your y value. Okay? So just a note there on that. But you, again, can come ask me questions throughout the week at lunch or after school or all those things, okay? You can do it tonight, page 1, and just say, whoo, done with that. Or you can wait till Sunday night and do all of it. It's up to you. You get to decide your own policy and see how it works out for you. But problem sets will help your grade if you do them well. All right, here's what I need from you. Stack those folders and what do you call them? Name tags. And then all of this stuff goes somewhere safe, preferably in your pre-cal folder binder that you're getting. And we will pick up on Thursday because I do not see you tomorrow.
What time of evening?
Yep. Thank you for reminding me. I would have just kept